Well, howdy there. This is a quick screen recording to show how the single point of compromise simulator can be used in LogSynth. To get ready for this, I've already created a VM to work in, and I've downloaded the LogSynth program. And the way I've done that is by going to GitHub, to tDunning LogSynth, and in the standard way, there's a URL there, and I get just used to clone. So now I have the LogSynth stuff right here in the directory. It's no big deal to compile it. I'm going to skip the tests in this particular case because this is a very limited memory machine, this VM that I'm running. But you can see that since I've already run this once, it really doesn't take very long, about 7.5 seconds to compile this. The result of the schema, or the compilation, is found in the target directory, and in particular, here's a straightforward LogSynth executable. This is actually an executable jar which is arranged in such a way that it is actually executable directly as a command. So let's get a schema for this common point of compromise. Let's edit the schema right here. Where we're going to get that is if we go over here to the README, this is the README for LogSynth, then we can just search for compromise, and here's the documentation for a common point of compromise. And here's a sample schema. So let's copy that, stick it into our file, schema.json. And before we close it, let's take a look at it. It's going to be creating two fields, one called ID, which is sequential integers. The other one is going to be history, which is a list of transactions. The class that generates it is the common point of compromise generator. Here's a seed so that we always get the same results. You might change that. We're going to run an exploit for just a few days from, well, about a month. That's how long the exploit's going to run. The compromise period during which the cards are compromised is set by default. Here's the end of the simulation. We could set that to anything we like. Compromised fraud rate and uncompromised fraud rate are set accordingly. There's more things you can set. You can look at the code to find out more about those. But that's good enough for us to run right now. So if we run target/logsynth, let's produce, say, 3 records. Schema is schema.json. And let's produce the output in JSON format. So boom, there's 3 output lines. Now these are enormous output lines. Here's the beginning of the third one. IDs are 0, 1, and 2. Then here's the history field. You can see it's an array. And it's a big array because it's got lots of transactions for that particular consumer. If we want to generate a lot of data, then we might want to, say, increase the count to some large number like 10,000, and let's use 10 threads and stick the output into a output directory. Well, actually, let's stick it into this directory that I used before called logs. Looks like I have to use an uppercase K for the count. So we're zooming along there. We just did our 10,000 records. If we look in the logs directory, you can see that there's 10 files, 10 JSON files, each of which contains a bunch of records. Now, to look at this, we could look at this like we did before with less, but that's really, really a pain in the butt. So what I did earlier, if we go up a directory, we can see here, I downloaded Apache Drill, the tar file. This is version 1.6. That changes about every month as to what the latest one is. I unpacked it into this directory. and I'm going to go back into the LogSynth directory, but that lets me run drill in an embedded form. The only thing I've done here after downloading and unpacking it is I decreased the amount of memory that drill is going to be using, because it normally uses 8 gigabytes of non-heap space direct memory, and that's too big for the tiny little VM that I'm using. So here's drill. Drill's now running, and we can do queries. So let's look here. For instance, select just the ID from the distributed file system, in case this is my home directory, in this directory. I'm using a directory as a table, and I'm going to look for 3 IDs. The first 3 IDs I get from all of the files in that directory. There it is, 9, 21, 31. Now these are not consecutive. They're not consecutive because drill is reading all those files in parallel. Those are just the first 3 that seem to come through. If I order by ID, you can see we get 0, 1, 2, or if I get more of them, all the ones you might expect. Now we can do various things like this. Notice it's figured out that the JSON is data, just like you'd kind of like it to do. If I do ID and flatten on the history, what that'll do is it'll make records that look like this. Each element in the history array causes a single record to be produced. So there's the ID 0. That's the ID that we had before. And here are consecutive history elements. Now, so we can do some kind of fun stuff there. What we can do is have that select be the source of our data. And now what we can do is we can select ID and count star from that same query we did before, but now let's group by ID, order by ID, and let's just look at the first 10. So here you go. You can see how many records there are in the histories for various ID records. 254, 54, 207, 37. It varies quite widely, as you can see. In fact, I believe it's generating from an exponential distribution. We can, from this, for instance, nest the queries once again without the limit, and we can now say select select average count from all of that. So the average is 177 or so records in each history element. So this is a nice way of seeing the data that we produced using LogSynth and exploring it a little bit using Apache Drill. Pretty cool, I think. Thanks very much.